Hello, everybody, once again. We're going to go through yet another paper. I'm trying to go through most of these before the exams. So this is 2019 Mechanics for LMS for Edexcel. Remember, I teach Edexcel, so it probably makes a lot of sense for me to do the Edexcel papers. I suppose we'll get right on it with question one. Question number one, then. At time t seconds where t is greater than or equal to 0, a particle p moves so that its velocity v meters per second is given by v is 6ti minus 5t to the 3 halves j. When t is 0, position vector of p is minus 20i plus 20j meters. Find the acceleration of p when t equals 4. Alright then. So we want acceleration. So if we want to get acceleration and we've got velocity, we just need to differentiate the velocity vector. So the acceleration is going to be differentiate the 6t will give us 6 in the I, and then the minus 5t to the 3 halves would just be minus 15 j meters per second. Yeah, that's it. Because this is going to be minus 15 over 2 t to the half. And when you sub in the 4, that's why I've cancelled it down to there. Yeah, because no 4 to sub in for the I component, it's just the j component we have to sub in. Find the position vector of p when t equals 4. Position vector, we're told about the distance, so we need to integrate v in respect to time. So if I integrate that, we're going to get 3 t squared in the I component, minus, what am I at? 2t to the 5 over 2 j, plus some constant r0, which apparently we're told in the question yes, we are told. We're told minus 20i plus 20j, so plus minus 20i plus 20j, which gives you 3t squared minus 20. I will flip to columns now. 20 minus 2t to the 5 halves. It's a lot easier, I think, for these, because I need to just sub in t equals 4, and I get r being 28 and minus 44 meters. Okay, so that's question one. Again, there's nothing too difficult with question one, but it's just, can you remember to integrate and differentiate? I should hope so. And it's vectors stuff, so should be fairly okay on these. Move on to question two, shall we? So a particle p moves with constant acceleration 2i minus 3j meters per second. At time t equals 0, the particle is at the point A and is moving with velocity minus I plus 4j meters per second. At time t equals big T, p is moving in the direction of vector 3i minus 4j. Find the value of t for 4 marks. Okay. So this is going to take a little bit more work, methinks. So there's 2i minus 3j that we're given here, we're going to need. This I minus I plus 4j we're going to need. And then it's moving in this direction of vector. So when t is big T, we know that v would be k lots of this vector. I.e., if the I and j components are in the same ratio, that means that they're in the ratio 3 to minus 4. Now that's going to be important for this part of the question, because we're told the acceleration, so we can get the velocity vector out, because we can just integrate it to give us 2t minus 2t in the I minus 3t in the j plus some velocity vector 0, which is 2ti plus 3 minus 3tj, plus minus I plus 4 in the j. Just adding on that bit that we're told in the second line, which I can tidy that up to give me 2t minus 1 in the I component, plus 4 minus 3t in the j. Okay. I.e., so 4 minus 3t, big T, or 2 big T minus 1 has got to be minus 3 over 4 using that fact. So we just need to solve for T. So we've got 12 minus 9t equals minus 8t plus 4. We can add that onto that side to get t plus 4 is 12, it will be 8 then. So the value of t must be 8. Hopefully very straightforward. So at time t equals 4 seconds, p at point B, find the distance A to B. So distance usually implies we're going to use some SUVAT stuff, I think, for part B. And the SUVAT I want to use, because I'm looking for distance, so I want the one with S in it, which is ut plus a half at squared. So S is going to be u, which is minus I plus 4j, i.e. minus 1, 4, write it as a column, times by time of 4 seconds, plus a half times the acceleration vector, which is 2 minus 3, times by 4 squared. What's that going to give you? So the 4 squared and one of the halves can cancel, so that'll be 8 lots of that. That's going to be 12i minus 8j, I think. Yeah. Well, that's the position of B, isn't it? So this is B, that coordinate there. Now, we already had the A coordinate because we know... what did we know? I'm trying to think out the way to do this. Oh, because we know this is the position of B, all we really need to do is find, for A to B, then, the modulus of this vector here. So we need to find mod of this distance. That's all we really need to do. So it's 12 squared add minus 8 squared. I don't know why I'm putting the minus 8 in there. But essentially, it's 12 in the I, minus 8 in the J. And we're just finding Pythag to work out this distance here. That's in a sense all I'm really doing. So that's going to give you 144 plus 64. So that's what, 4 lots of that, which is 4 root 13. I should really be using a calculator for this instead of testing it in my head. But that's what I think you should get. I know my writing's a little bit messy on here, but hopefully you can hear me talking to you, so it should be easy to write down what I'm saying. Right, on to question 3. Right, so we've got a pulley going on. Yay, I like pulleys. I like pulleys quite a lot. So we've got a Let's read the question first. Two blocks, A and B, of masses 2m and 3m respectively, are attached to the ends of a light string. Initially, A is held at rest on a fixed rough plane. The plane is inclined at angle alpha to the horizontal ground, where tan alpha is 5/12. The string passes over a small smooth pulley P fixed at the top of the plane. The part of the string from A to P is parallel to a line of greatest slope of the plane. Block B hangs freely below P, as shown in Figure 1. The coefficient of friction between A and the plane is 2/3. The release from the string when the string's taut, A moves up the plane. Tension in the string immediately after the blocks are released is T. The blocks are modelled as particles and the string is modelled as being an extensible. Show that T is 12 mg/5. Alright. To be fair, reading that, we're not actually told very much, are we? So we've got tension, we've got the weight of this thing being 3 mg. I've got an all reaction coming off. I know the tension's going that way, I know it's going in that way in motion. So it means my frictional force, my mu times r, will be coming down the plane, and my weight of this is 2 mg. So I can clearly see what's going to happen here, because I can resolve. I should also make note of the tan alpha bit, just so I don't forget. It's 5/12, so it's a 5, 12, 13 triangle. So from here, we can just get sine alpha out as doing opposite over the hypotenuse, so it'll be 5/13. And cos alpha is 12/13. Just because I might need them later, so I might as well make note of them now. So, we need to find what the normal reaction is. So let's just split in this into component parts to get via there, which is 2 mg. And because it's crushing the angle, it'll be cosine alpha. It's up to you if you want to rewrite it as 24 mg/13. To be fair, I don't think it really matters at this stage. It's a little bit early on. The frictional force, so Fr, which is equal to mu times r, which was 2/3 for the coefficient of mu, multiplied by the 24 mg/13, which gives you 16 mg/13. Yeah, that's right. So, we're going to do F equals ma on A. That's what I'm going to do. So we're doing T minus the frictional force, which is 16 mg/13, minus the component of the weight, which will be 2 mg sine alpha. And sine alpha works out as 5/13. Is going to be equal to the mass, which is 2m, come doing A, multiplied by the acceleration, which I don't know. So that's going to give you T minus 2 mg equals 2ma. And we'll call that equation 1. Now I need to find equation 2, so I'm going to do the same thing, but I'm going to do it for B now. And I know B is going to move downwards, so I'm going to get 3 mg minus T equals 3ma. Or you could just do minus T plus 3 mg if you like, so you can see the T's will eventually eliminate by me adding these two equations together. So I'm going to do 1 plus 2, because I'm solving them simultaneously. So I get mg equals 5ma. So I get my acceleration to be g/5, which I can then sub in the other one to be t being 2mg, or 2m rather, times by g/5, plus this 2mg to the right hand side using equation 1, which will give you 2m times g/5, which is 200/5, plus that'll be 10/5. So 10/5, 2/5 gives you the 12 mg/5 is required. Again, 8 marks for that is a little bit of a gift on an exam like this. Just to forewarn you, if you make a slip up in your equation of motion for one of them, you will mess up the rest of them. So if you only probably get the maximum of 1 or 2 marks. I think doing it in stages like this sort of shows you like the method you need to be thinking about when you're doing these sorts of questions. And automatically, there's like a method I go through. I find what R is, I find the friction I need to know, and then I work out my first 2 equations and think about how I can eliminate them. You can, if you wanted to, eliminate the acceleration. So if I just mention this here on this question, just so you know, I've got a 2ma and a 3ma to eliminate. So it might be that I multiply one of them by 3 over 2 and equate the 2 things together and resolve for t. That's also a valid method for these. To be fair, as long as you show that t is 12 mg over 5 is a valid method, you will get the marks for it. That's what Edexcel say anyway, and that's what I go off. Okay, I need to move down the page, don't I? So, I'll move on to the next page. I hope you've got a screenshot of it. Okay, got some more interesting bits now here. After B reaches the ground, A continues to move up the plane until it comes to rest before reaching the point P. And P was the pulley. Okay. Determine whether A will remain at rest, carefully justifying your answer. Alright. So, I think it's worth drawing a diagram again for this. Now, you don't have to. That's the thing. You didn't need to draw a diagram for this, if you didn't want to. You could happily get away with doing it without the diagram. So, there's my diagram. This is my block. This is A. Now, this was my mu r. My weight was 2 mg. And when I broke it into component parts, this ended up being 10 mg over 13, didn't it? So, we can clearly see that 16 mg over 13 is clearly greater than 10 mg over 13. So, A not move. Very simple. And the last bit then, so just 2 refinements to the model that will make it more realistic. So if the string was extensible, I would also make sure that I include some friction on that pulley. Because if we include friction on the pulley, it makes this a lot easier, doesn't it? Well, say it makes it easier. It doesn't make it easier for us, but it makes it easier for considering it in real life. Alright, let's move on to what I consider the toughest question on this paper. Let's have a read of it. Here's question 4. I remember this one coming up because no one liked it. Yeah, this will be fun. So we've got a ramp AB of length 8 meters and mass 20 kilograms, resting in equilibrium with the end A on rough horizontal ground. The ramp rests on a smooth, solid, cylindrical drum, which is partly under the ground. The drum is fixed with its axis at the same horizontal level as A. The point of contact between the ramp and the drum is C, where AC is 5 meters, as shown in figure 2. The ramp is resting in a vertical plane, which is perpendicular to the axis of the drum, at an angle theta to the horizontal, where tan theta is 7 over 24. The ramp has model's uniform rod. Part A, explain why the reaction from the drum on the ramp at point C acts in a direction which is perpendicular to the ramp. Okay. That takes you a minute to absorb everything, doesn't it? Right. So, I think what it's trying to make you think about is that the answer is actually given to you. Funnily enough, they give you the answer to it. Why they're giving you the answer, I don't know, but it's in the second line. Now, if you spot it, it makes your life a hell of a lot easier. And quite simply, I will write down the bit that I'll highlight the bit that you actually want in this. In the second line, it says the ramp rests on a smooth, solid cylindrical drum. So the fact that it's smooth, so because the drum is smooth, the reaction force is only from the normal reaction. And hence, it's perpendicular. Not easy, but there you go. Alright, and now we've got this meter of a 9 marker, and this is one of the reasons why I think this question was answered really badly, because people only got about 25% of the marks on this question. So you can probably imagine it's going to be quite a hard question. So, find the magnitude of the resultant force acting on the ramp at A. So I think it makes sense that we redraw the diagram. So let me zoom in a little bit. Much better. So, we need to consider all these forces. Now, the reaction force is acting this way in this case. So that's RR. But my plan is to get the components of that and to use Pythagoras to get the value of R. So I've got the weight of the thing, which is 20g. My normal reaction I now know is perpendicular, and I can then break that apart because it's at the same angle of theta. So this would end up being n cos theta, and that would be n sine theta. We were also given that tan theta, if I remember rightly, was 7/24. So sine theta would be 7/25. That's another Pythagorean triplet. And cos theta is 24/25. So, 3 things you can do in these moments questions. Resolve left and right, or up and down, or take moments. I'm going to resolve that way and that way, first of all. So I've got an x, and I've got an n sine theta going the other way. When you actually tackle this question, it doesn't look half bad, does it? And then I need to resolve the other way, up and down, before I take moments. So I've got a terrible cough here today, but I'm still pulling through for you guys. I've got y plus n cos theta, and I've got that being equal to the weight, which is 20g. So y plus 24/25 n equals 20g. Then I take moments about A. So I've got this n force times by the perpendicular distance, which is 5 meters, equals the anti-clockwise moment, so the 20g, multiplied by the perpendicular distance. Well, we know the whole thing is 8, is uniform, so the weight will act 4 meters up. And I've got this angle here. So actually, this is just 4 cos theta. So if you draw a little diagram like that, and that's theta, and that's 4, then this will be just 4 cos theta. And that'd be 4 sine theta on set. Okay? So it's 20g times 4 cosine theta, which I now have a value for cos theta. So I can rearrange for n. This is when I do need my calculator. And what's that going to give you? 150.5, something like that. 0.528. I end up getting on my calculator. Okay, I have the way there now. That's good. Problem is, I'm not done yet. I need to find what x is and y. So x would just be that times sine theta, which is, according to the calculator, 42 and a bit. And the y value is 20g minus 24 over 25n. Rearranging the equation up here, which gives you 51.493 and a lot of other rubbish. Okay, I've got x and I've got y. I want what r is. So r, what I want to end the question is x squared y squared square rooted. Bit of Pythagoras. And plugging them in, you get 66.5 newtons to 3 significant figures. Now, I don't think people did a lot of questions like this. And I think that's one of the reasons why people didn't do so well on this question, because I don't think people's done many like it in lessons, and I think they've just a bit collapsed on the question when they've seen it. The last bit, the ramp is still in equilibrium in the position shown in figure 2, but the ramp is not now modeled as being uniform. Given that the centre of mass of the ramp is assumed to be closer to A than to B, okay. State how this would affect the magnitude of the normal reaction between the ramp and the drum at C. Now, it's just a state, so you don't have to give a full explanation on this. But quite simply, if I moved the centre of mass further down, then it's not going to tilt as far, so it's just going to quite simply decrease. The magnitude of decrease in our reaction at C because you have a lower moment. Okay. And again, it's only worth 1 mark, so if you put increase, it's not 2. It's not the end of the world, it's only 1 mark. Alright. This is the last question, number 5? Yes, it is. Question 5, the last one then. Last one, guys, we're nearly there now. We've got a projectilesy question to get on with. Oh, lovely. So the points A and B lie 50 meters apart on horizontal ground. Of course they lie on horizontal ground. Right. Time equals 0. 2 small balls P and Q are projected in the vertical plane containing AB. Ball P is projected from A with speed 20 meters per second, 30 degrees to AB, and ball Q is projected from B with speed u meters per second at angle theta to BA, as shown in figure 3. At time t equals 2, P and Q collide. Until they collide, the balls are modeled as particles moving freely under gravity. Find the velocity of P at the instant before it collides with Q. Okay. I can deal with that. That's not so bad. So, the first step is v equals u plus at. If we look horizontally, there's no acceleration to deal with, so the component horizontally would just be 20 cosine 30. And the vertical component would be 20 sine 30, which is u, minus 9.8, because I'm taking upwards to be positive. So my g will end up being negative, times by 2 seconds. And that gives you minus 9.6 meters per second. So the overall speed is Pythagoras of root 20 cos 30 squared plus minus 9.6 squared, which gives you 19.823 significant figures. And it wants me to tell me the velocity, so I need the direction, don't I? So I've got 20 cos 30 going across, 9.6 coming downwards. I want the angle. So theta then is just inverse tan of 9.6 over 20 cos 30. Calculator wise is giving me about 29 degrees below the horizontal. Find the size of the angle theta and the value of u. Okay, so equation is going to be S equals ut plus a half at squared. Okay, I've got enough information to do that. Horizontally, I can just use S equals ut, so I can just use 50 is equal to u cos theta times by 2 plus 20 cos 30 times by 2. I get u cos theta then being equal to 25 minus 20 cos 30. If we look vertically, they will collide at the same point, so we've got equal distances going on. So we can set up an equation that 20 sine 30, the component of that, times by the 2 seconds, minus a half, times gravity times by 2 squared, is equal to the component upwards of the u, which would be u sine theta, times by t equals 2 minus a half g times 2 squared. What's that going to give me? Will this give me 20 sine 30? Or 10 in other words. It's a lot easier. So I've got u sine theta, u cos theta, so I can get tan theta divided by one by the other. So I've got 10 over 20 cos, 20 over 25 minus 20 cos 30. So theta then is approximately 52.47, something like that. And then I need to find what u is, summing that in there. So u then, just summing it back in to one of them, gives you about 12.608. So around that 12.6 meters per second. 3 significant figures. State one limitation of the model other than air resistance that could affect the accuracy of your answers. So I always go for spin on these because I think spin is one of the easiest ones that you can think of. Wind is also not a bad shout if it will blow it off course. That would also have an effect. the size of the balls as well, or the particle's weight, maybe, we have to assume. There's loads of things. So, one limitation, so it doesn't account the spin of the ball. And that would do. Alright, that's the end of the paper. So, I hope you enjoyed that little walkthrough there. It is out of 50 marks, so, that's an easy, as I say, an easy 50 for me. Yeah, I quite enjoyed that paper. Thanks very much for watching. See you in the next one.